All right, guys, welcome to PyCon 23, your first OpenTelemetry tutorial. So, before we start, I just want to thank everyone who's working here and volunteering and helped make this thing possible. You're all doing an amazing job, so thank you all very much. So let's jump right in. Okay. Welcome to how to monitor and troubleshoot applications in production using OpenTelemetry. So, this, I believe, is the #1 most comprehensive tutorial for OpenTelemetry that exists. I wish I had this when I was starting out because this would have saved me a lot of time. So that's what I hope to do here today for you. And I hope to cut you all a lot of time and cut you little corners, and maybe we can all learn really fast today. So, does anyone here know what OpenTelemetry is? Is anyone familiar? Please raise your hand. Okay, a good amount. And everyone who doesn't know what OpenTelemetry is, please raise your hand. Wow, most of the class. All right, well, welcome. So we'll get right into it, but there's a lot of backstory and a lot we need to know before going into it. We need to define observability at first. And the way that I would define observability, and this is really the standard now, is measuring the internal state of a system, and it's how well you understand what's happening inside, given only the external outputs. Okay, so you're watching something change from the outside, and you kind of have a smarter and educated guess as to what's really happening inside. And so we can start with a few examples. We can see, for example, a person aging here. And can anyone raise their hand and tell me what's happening to this person as they're aging and getting older and older? No one knows? Exactly. So you summarize basically in a couple words. He's losing hair, he's growing whiter and whiter hair, and just a few small changes outside. And same with this star that's burning, right? We're basically summarizing what we're seeing in a few words, but these don't really capture what's really happening. There's a lot happening behind the scenes for both of these events. There's millions and millions of tiny events happening inside that we don't know. And every year we're just learning more and more and making smarter and smarter guesses as to what's happening. So that's exactly what we're trying to do here. We're trying to observe, but not a person that's aging or a star that's burning. We're trying to observe modern day applications, right? Applications for the cloud, cloud native, in distributed environments, and so on. And so we need some data, basically. Just like we have microscopes and lenses, and we're able to see the sun, and we're able to get smarter and smarter and educated guesses, we need some information on the application side as well to figure out exactly what's happening. So observability for modern applications are built on top of 3 main pillars: metrics, logs, and traces. Okay? Metrics. Can anyone raise their hand and explain what metrics is in their own words? Do they have an idea of what it could be? Yes, please. Exactly. It's series of numbers that add up, and really they just measure activity, and you can display them on the graph, and you can have all sorts of fun with them. And traces as well. Traces are a bit more abstract. They're really the cooler part of observability. That they're a document-based metadata, really, that contain all the information of one microscopic atomic event, okay? So when we see here this image of a trace, what we're really looking at is spans coming together. Feel free, guys, come in, don't be shy, it's okay. Welcome. So what we're really seeing here is a collection of spans. A trace, you should think of it as a big family, okay? And each one of these little circles that you see here, this is what we call the root span, the first one. And each one is a span we see here. So this would be the root span. Each circle span you see here would be a child to this parent span. And I guess each circle span, you can think of it as a sibling. Okay? Is that a question?
It's sticky.
Oh, okay. Yeah, don't sit there. Okay, are there any questions so far on metrics or traces? okay? And logs. We've never heard of this, right? Just kidding. This logs is your normal standard output, standard error streaming. It's what you see when you do print hello world. It's exactly that. So logs as well. Together, these come and they form a stack of telemetry data that we call MELT. Metrics, traces, logs, right? So when you have only one of these, it becomes really, really hard to monitor and debug your application. When you have two, it becomes slightly better, depending which two. And really, when you have all three come together in a concise and consolidated place, in a single pane of glass, it becomes very, very easy to quickly debug, monitor your applications, and stay on top of everything. Any questions so far up till now? Okay, amazing. Class full of geniuses. So, welcome. Next, we'll get into what OpenTelemetry is. So, OpenTelemetry, you should think of it as, I guess, you should think of it as a collection of tools and APIs and SDKs, okay? And they do four main things. I'm not exaggerating when I list out all these words here. They instrument, they generate, they collect, and then finally they export telemetry data. This is all that OpenTelemetry does. It does these four main things, and we'll get really, really deep into all of those, okay? But what you should really think of it as, OpenTelemetry is just one protocol just to extract telemetry data out of your application and to be able to do something with it later on. Okay? Any questions on this? Okay, excellent. So we're going to look at it at a high level, what really happens. So on the left side, on the blue, you have your demo client, demo server. Ignore those. Those are just your applications that you wrote in Python. You wrote a hello world in Python. Okay, that's the blue. From there, OpenTelemetry does what we call instrumentation. And it's able to extract telemetry data from your application and export it somewhere else. So your application, it exports it to an OTel collector, an OpenTelemetry collector, okay? A collector, you should think of it as a queue or a sort of bridge or a bus or a highway that's just an intermediate stop for your telemetry data before it reaches really its final destination. Your data will never live in an OTel collector. It'll just stop by there for a little bit before advancing on and moving on somewhere else, okay? And finally, we're going to export it today to three main places. And these are really your telemetry backends. This is the final stop and the final place for it to end. Okay, we're going to send it to Jaeger. It's an open source tool for distributed tracing. Zipkin, also for distributed tracing. And Prometheus for metrics. Has anybody heard of Jaeger? Please raise your hand. Okay, good amount. Zipkin? Less. And Prometheus? Everyone. Amazing. So I'm sure you heard of Prometheus at work. I've definitely heard it many, many times before I really found out what it was. And that's exactly what we're going to be doing today. We're going to be creating your application, sending it to an OpenTelemetry collector, and then finally exporting it to these three main places. Okay? Keep in mind, you can send it to a lot more places. These are just vendor-neutral places. They're open source telemetry backends that you could send it to. But for commercial options, you have many, many, many options out there. Any questions on the high-level architecture? Okay. Anyone not understand anything? Okay, let's move on. So let's go a bit more in depth now. What it really means. This is exactly the same thing as this diagram, just much more in depth behind the scenes. So let's start with your platform in the blue. Your platform, you should think of it as any place where Python 3 can run. Say an AWS EC2, a Lambda function, it doesn't matter. Your computer, it's all the same. OpenTelemetry sits in between your libraries and your application. It sits in between. Can anyone guess why? Please raise your hand. Nobody has an idea. Exactly. It's able to intercept your libraries, and it gives you, let's say you have requests, the request library. You don't really access your request library exactly as it is. You access a OpenTelemetry instrumented version of your request library, because it's able to intercept all of your third-party libraries before you even access them. Any questions on the interception instrumentation?
So, is that for a specific library? Does there need to be a request version of OpenTelemetry?
No. It does it on the spot, on demand, right before you run your code. So yeah, it becomes very, very easy. That's the cool thing about Python, that it's interpreted. Everything just happens on the fly, last second, and it's scary but cool. Go ahead. Good question. I guess we'll find out. But but you're right. It's not my favorite idea that it intercepts your packages at runtime, and it's able to maybe possibly mess up and give you a dangerous version of your application. So this is the idea of monkey patching, and so we're making it safer and safer, and we're adopting community standards to make it as safe as possible. Any other questions? Both. It's your application. You'll do it soon. Pretty much. Yeah. You'll do it on your computer locally. So the application is any piece of Python code that runs. It's just a very generic vague. And yes, a question in the back? The overhead, a bit less today, but we can go into that if you want at the end. Definitely. Okay, so any questions on the interception and instrumentation? Okay, perfectly. So it's able to instrument, and so what happens when you do, for example, request.get google.com or bing.com or anything? What happens is the API and SDK work together first. And the blue and the green here, they're able to do what's called generating the trace. And what it is essentially a big JSON or a dictionary in Python that contains all of the metadata about the operation or event. And from there, it's sent on to a processor. The processor, you should think of it as simply a sort of a queue that just handles it before it's being sent out. From there, when it leaves this queue, it goes to an exporter, which is another sort of queue. But when it leaves the exporter, it's sent out through the internet to anywhere you want it to go. Okay? Usually the first stop from your application is an OpenTelemetry collector. You don't have to use the collector. We'll get into it. But the collector is sort of optional. Because as you see, the collector also has an exporter. So you could send it directly from your application's exporter to the telemetry backend. And the collector is optional. But this is part of the overhead question, that it reduces a lot of stress from your application when you send it directly to the collector, as local and as close as possible. Just send it out quickly. And then all the overhead is on the collector, really, to do all of this. Any questions on the application side? Go ahead. It's your choice. You could configure sampling. Go ahead.
Is it strictly through blocking calls, or does it actually hook callbacks and async routines as well?
Does it block the call?
It sounds like you're hooking and patching into all blocking calls. Request.get.
I got you.
Does it also do anything for callbacks where you pass in a callback to get called later or routines?
I'm sure there's a way to configure it, but by default, no. I mean, it doesn't block anything. It does it all kind of at the same time. Anything else? Okay. Let's move on. And so we'll move on to what the OpenTelemetry collector is. The collector is really just a place to offload really stress from your application and put it all in the collector. It's a different piece of architecture. It could be, I guess, for example, its own EC2, or it could be anything else. And it's just this tiny little thing that's able to receive traces and send it back out to somewhere else. So what it is almost the exact same thing as what we see on the left. Although instead of creating it, creating the traces and spans with the API and SDK, we're just receiving it. We're listening, and oh, we got a trace come in from this exporter. From there, it's sent on to the processor, just a small queue, and there to the exporter, and finally, it's sent to a telemetry backend, someplace that can store your data, and then also hopefully visualize it as well. Because having just data in a database doesn't really help much. You need a way to also see it and interact with it somehow. So any questions at all about the architecture, high depth and low depth as well? Okay, great. So let's move on. And hopefully everyone has... Yeah, go ahead.
I mean, I've seen benchmarks and this sort of thing, and I was kind of unclear at one point whether or not this benchmark markdown file was talking about the number of messages that it could get, or like I think bytes or something like this. So
I've seen in enterprise situations, I haven't had much, I haven't seen many problems of the collector handling stress. I've seen in enterprise applications where they just have a really big EC2 or something like that, and it's able to hold everything, and it does it very well. Yeah, in the back. Could you repeat that? I couldn't hear.
Do they usually co-host like the collector as like a separate process on the same machine, or is it usually its own?
Usually it's separate, right? Because we want to offload as much as we can. Today we're going to co-host. We're going to have the application and the collector and the backend all running on your computer today. Okay? So we're able to see how it's all possible, but you could easily split it up. And so I hope everyone here has Python 3 and Docker installed. Does anyone not have these installed right now? Okay, so just make sure you have. Are you able to run Docker Compose? Okay, I recommend you have Docker Desktop, but good luck if you have an alternative. Okay, so if everyone's here on my repo, is anyone not on my repo right now? Okay, perfect. So just go to GitHub, and it's basically this. This is the username, and this is the repo over here. Awesome. So this is it today. It's basically, like, you could think of it as a big tutorial, a big blog post, but it's basically just 17 small steps. We're going to do them all together. Hopefully stay with me for the first couple, 4 or 5 steps, and from there you could go at your own speed. You can go as fast as you want, and I think if you go fast, you could do this in around 20 or 30 minutes, and you're free to go. I mean, you don't have to hold you here for a couple hours. But you can go with me at my slow pace, and we can have a good time. So, perfect. Let's start with prerequisites. Number 1, I want you to git clone this repository and have this locally. Why? Because it has a few YAMLs that are going to help you to run everything, and you don't have to copy paste a lot of boilerplate, basically. So just clone this and give me a thumbs up when you're done. Okay, awesome. Most of the class. Should take a couple seconds so we can move on. And while we wait, I want to ask you a couple more questions about your experience in Python, Flask, and OpenTelemetry, I guess in general. Who here is in their first year of learning Python? Wow, nobody. That's amazing. Who here is 5 years or less? Raise your hand. Okay, a small number. And who here is 10 years or less? Okay. Is anyone here over 10 years? Wow, veterans. Thank you so much for coming. I really appreciate it. I have a lot to learn from you, so I'm going to ask you a couple more questions at the end. Who here has used Flask before, either at work or at home? Okay, almost the entire class. Amazing. Does anyone here not know what Flask is? Okay. And OpenTelemetry and Observability, has anyone worked with these or is familiar with these before they came in today? Yes, could you guys just talk one sentence, I guess, about your experience?
I work on API Elastic actually, so just exploring other products as well.
That's amazing. And yes? Oh wow. Okay, so this is a bit more in the future, I guess. And anyone on this side?
The distributed tracing makes debugging much easier.
Yeah, definitely. Okay, anyone else want to share? Okay, perfect. So let's jump right in. Step 1, just go into this directory, collector demo, cd into it. On Windows, I'm not sure, so I'm going to be using only Mac and Linux commands, okay? I'm sorry, guys. And step 2, I want us, because we're going to be writing some really, really good code today, to be able to write good code, you have to read good code. So we're going to be reading some code just a tiny bit, just to understand exactly what we're doing here. And then from there, we're going to go on to writing, okay? So let's start with docker compose.yaml. And I have it right here. And if we can close this. Basically, Docker Compose. Does anyone here not familiar with Docker or Docker Compose? Okay. So the entire class is familiar with Docker. Yeah? You're unfamiliar? Does anyone want to explain it in a couple words, just maybe 4 or 5 words? Okay. So essentially, you could think of it as a tiny little VM that runs inside your computer. And you're able to run almost any operating system or any little I guess, base, they're called images. That's what the word we're going to be using. Oh, okay, perfect. So that's exactly what it is. That's what Docker is. And Docker Compose is just a way of running a bunch of images all at once on your computer. That's all it is. So perfect. We're going to be running a few images together. The first one is Jaeger. This one is for distributed traces. And we're going to be using Jaeger tracing / all-in-one at the latest version. And we're going to be using at these ports. This port is the port for the UI. When you go to your browser and you're going to be looking at it, you're going to go to this port, 16686. The following two ports are only for accepting traces. So it's going to set up a little server on your computer, and it's going to be listening for traces on these two ports. Okay? We'll come back to these later. Any questions on this? Go ahead. These two are the default, but it has a lot more default. It has also 4317, 4318. It has a couple. So you can configure it however you'd like. You can also reroute it to any other port you like. Anything else? Okay. That's nice. So Zipkin, also for distributed traces. We're going to be using this image, OpenZipkin /Zipkin at the latest. Okay, and Zipkin runs only on one port. This is the same port for listening for spans and everything else, as well as the UI. You're going to access it at this port, 9411. Any questions on Zipkin? And the next is OpenTelemetry collector. Okay, so this is the exact same collector that we saw over here, the exact same one as we saw. And the collector is, so what we're going to be doing here is notice that the volume. Does anyone here not know what a volume is? Okay, perfect. So we're going to be setting our local file, otel collector config.yaml, and we're going to be throwing it inside of this container at this path, /etc /otel collector config.yaml. Okay, and from there we're going to say, hey, when you run my container, please set the config equal to this exact same file that I just threw in the container. Okay, so it's our easy way of saying, my custom configuration, I want this inside of the container. Is anyone confused about this part? Okay, moving on. And we've got a bunch of ports open. Don't worry about most of these, but the one you should know is 4317. This is where the collector is going to be listening for incoming spans and traces. Okay, 4317. And we're going to be using this port a lot today, actually. It depends on Jaeger and Zipkin to be running. So first, those are going to be up and running, and then the collector will go up. And then finally, Prometheus for metrics. Okay, we're going to be running this image from Prometheus at the latest version, and we're doing the exact same thing with our volumes. We're going to be saying my local file prometheus.yaml. I want it to be thrown inside of this container at this path /etc /prometheus/prometheus.yaml. Okay, and same port. This port is for accessing the UI, and we're going to access it pretty soon. Any questions at all about Docker Compose? Go ahead. It's why it's under the collector, you're asking? It's a good question, because we'll get into that actually in a minute or two. I just want to go over the... So any other questions about it? Okay, so I want to get into the OTA collector config that we're talking about. And this actually took me a bit to learn, and I kind of didn't understand that at first, why it was the way it was. But when you look at the architecture, it actually makes a lot of sense. It's comprised of three things: the receiver, the processor, and the exporter. That's all it is. It's only three things. And you have to clearly, explicitly define all of those in your OTA collector config. So we're going to say, I want to receive spans by this protocol. OTLP means OpenTelemetry Protocol. It's a standard OpenTelemetry. And I wanted gRPC. gRPC is a Google protocol for compressing requests before they're being sent out. Any questions on the receiver? Perfect. The processor, very simple. We're going to use the standard batch one. For almost everything you're going to do, you're going to use the standard batch one. You can have some configurations if you'd like, but we're not going to do anything crazy. And then for your exporters, we're going to have to explicitly say exactly where we want to export it to. The first one is Zipkin at this endpoint. So go to the Zipkin container, go to this port, 9411 where it's listening, And at this path, it's going to be listening for spans. /API /v2/spans. Okay, almost every single telemetry backend will have some /v1/v2/something path at the end of it. Okay, any questions on Zipkin? Perfect. For Jaeger, same thing. We're going to be saying send it to this endpoint, the Jaeger all-in-one container at port 14250, and the TLS insecure true just means that even if there's no SSL and there's no encryption, it's okay. Just make the connection happen and just make it work. And finally, Prometheus, we're going to be sending it to this endpoint 000, which is just localhost at 8889. Any questions on Prometheus? Okay, perfectly. And finally, we're going to be using the built-in logging one. So this just means that the collector itself is going to be logging everything that comes in. Okay? Extensions, we shouldn't worry about them today. But ideally, if you're running your own application, you're starting from tomorrow when I'm not here, you should use the health check one. It's pretty good. But all of this, when you write your file, is kind of useless if you don't define it in your service. The service is really what's going to be run at the very end. So in the service, you define whatever extensions you like. You could run. We could remove the extensions here, and it wouldn't have a major effect on us. But you have to say, within the service, I want this pipeline for traces and for metrics. So I want, for traces, I want to receive them with my OpenTelemetry protocol. I want to process them with batching. And then I want to export it to these three places: logging, Zipkin, and Jaeger. Okay? And for metrics, almost the same thing. I want to receive it with OTLP. I want to process it with batching. But I'm going to export it to these two places: logging and Prometheus. Okay? So, Zipkin and Jaeger for tracing, Prometheus for metrics. Any question? Okay, perfect. So we can move on to Prometheus.yaml. This is the last one. So Prometheus works a bit differently. It's going to, instead of pushing to Prometheus, which we're going to do also, but it's also going to pull from the collector. So that's why we're going to basically be scraping with Prometheus. Okay, so we're going to say, go to this container, OTA collector, and every 10 seconds, I want you to scrape these two static targets: OTA collector at port 8889 and OTA collector at port 8888. Okay, does that answer your question? Because Prometheus is going to be pulling instead of pushing. So any questions at all about these three files we just went over? Because each one has a slightly different reason to be. Basically, we can see over here, this one is Prometheus metrics exposed by the collector, and this is Prometheus exporter itself metrics. They're slightly different, but we can read up on more over that later. It doesn't really have a major effect. Anything else? Okay, perfect. So back to the README we go. And I have just one question for the class. Over here, this side note. So the main difference from the computer's perspective, not from our perspective. Imagine you were the computer. The main difference between Jaeger and Zipkin is that Zipkin runs as one process. This includes the collector that's listening for spans, the storage of them, the querying service, the UI, and they also didn't even list a few, amongst others, okay? All of this runs in one single process. Okay? Jaeger is a bit newer than Zipkin. It came out more recently. And they introduced this concept of saying, no, we're not going to do it all in one process. Each one is going to be a different process. One being the collector, another being the UI, another one's the query service, and so on. And we can even see it over here in our files when we say in Docker Compose, for Zipkin, we just run the Zipkin image. But for Jaeger, we have to say we want specifically the all-in-one. Every single process, I want them all together. Can anyone guess or tell me why that is? Why did Jaeger split it up? Go ahead. Scaling. Perfect. It's built more for distributed systems. That's exactly it. You can have each single process running on a different computer. And that's exactly the right reason. Good job. So any other questions so far? Awesome. You can skip this one. And when you enter, you should be inside of the directory already, collector demo. Just run Docker Compose up and raise all of the images together. Well, I'll do that with you. So pretty viewable. Docker compose up. And cannot connect to Docker daemon. Does anyone know what you do here? Nobody? Then I'll tell the class. Start Docker, exactly. So we have it up and running, it's starting. Okay, perfect. How's this up? Let's delete it. Okay, perfect. So let's run that again. Docker compose up. And we should see the logs for everything come in. This is Zipkin. This is the collector. We have Jaeger over here. And so on. And we should see Prometheus as well. Perfect. So our logs are ready. That means the collector is up and running, along with Jaeger and Zipkin and Prometheus. They're all up and running. They're just listening and waiting for spans to come in. So at this point, you can go at your own pace. You can go as fast or as slow as you want. But I'm here for everyone. I'll go at the slowest pace possible. So good luck to everyone if you're going fast. Yes?
I did it while you were talking, and it took about 8 minutes to download everything for me, so probably a little while.
You finished everything?
Oh, it's downloaded, yeah, but it took 8 minutes
What's downloading?
for all the images.
Oh, wow. Just the images. Okay, okay. I'll wait for the images to be downloaded. You have a what?
I have a permission error. The config file is not readable, so
Config file unreadable? You want me to take a look? Okay. Sure, just give me a thumbs up when everything's up and running and you have all the images. So, a couple. I'll wait for everyone else. Thanks for your patience, guys. It turns out that the link 000 at the port of the telemetry backend, it might not work if you're on Windows. You might have to put localhost instead, or 127.0.0.0.1 yourself. So sorry about that, guys. Sorry about the inconvenience. So once everything's working with Docker Compose, you should be able to access it here. I can actually push the changes locally and push it up, and I mean, as long as you have the tab open once, you can just keep it open. Downloading, we can move on because the next steps don't require this. So we'll move on to step 6, and let me know if I can slow down and help anyone else. So step 6 is our base case. This will be our normal Python application with no instrumentation, with nothing else. We're just going to create this file once, and we're not going to edit or touch it again. Okay? So as it says, create a Python file by this name. So just to make sure I'm not mistyping, I'm just going to copy paste here. And I'm going to do Command D to split the screen. And I'm going to be doing this a couple more times because it's very, very helpful and useful. So in our directory, I'm going to be creating this file with touch. And then over here, let's just cleaning up a little bit. So we're going to be repeating this step. We're going to create our file with touch. And once we have that file, we'll go in. We'll just copy exactly as it is. Does anyone not understand what this file does? Can someone please raise your hand and explain? You don't even have to raise your hand. Just explain to me exactly what this file does. Yeah, exactly. Exactly. I couldn't have said it better myself. It sets up an API with 2 endpoints, slash and slash error. That's all it does. For slash, it will return hello world from our plain Flask app. In slash error, we'll do some arithmetic that's a bit hard for the computer to do. And we're going to be running this locally at port 5000. I'm not sure about Windows. If you have to change this to localhost or 127.0.0.1, then please feel free to do so. But on Mac and Unix and Linux, it should work. Mm. Okay, I understand. So we'll do that when we get there. We'll change it for all the Windows users. We'll change it to the right thing. So in our file, I'm just going to be dumping this all in, and that's it. And let's install our dependencies. The only thing we have is Flask. So let's clear this. I'm going to be using a virtual environment. You don't have to. If you don't know what it is, it's okay. You don't have to worry about it. Just install it normally as you would. So I'm installing Flask, our only requirement up till now. And it's installed. And let's go back and do it exactly as it says. Open 2 terminals, so make sure you have 2 empty terminals. You have your collector here and one more. So I have top and bottom. You could have it side to side. You could have it diagonal and swirly and whatever you like. So on one of them, we're going to be running our Flask base. And I have to do allow to accept incoming connections. And we're up and running. I'm going to just make the collector a bit smaller. We don't really need to look at it. It'll just be for fun. And we see that we have exactly this. On localhost port 5000, we have these 2 endpoints. So we could curl a localhost, but what it really is has anyone here not used curl before and not know what it is? Okay, perfect. So we'll just do it as it is. We're curling localhost at port 5000 / and we'll return our string hello world. You could do it without the slash as well. It's the exact same thing. Hello world. We're able to see over here that 2 connections came in, a get from this address, and they returned the 200 for both of them. When we reach an endpoint we don't know, for example, unknown, we'll get this weird HTML, and that's because it's... Can anyone tell me why it returns HTML? Why does it not just return an error message? Again? Exactly, but why is it HTML? Why is it not just a string that says, hey, here's your error with the stack trace? Oh, okay. So I didn't know you could change it, but from what I understood, it's really because it's meant to be opened in the browser, and now it makes sense that it's HTML. It's not found, it's nice and readable, and it makes much more sense. So when we reach something we don't know, we get a 404, and we don't really know why it's known or unknown. And then when we reach something that we know will cause an error, and the computer will struggle with this one, we get a big error message, 500 internal server error. We get a big error stack trace over here. But let's say, for example, we're looking only at this screen, because you're the user, right? And you reach some website and you get this 500 internal server error. I want you to answer a couple questions for me, okay? One, I want you to tell me what happened. You're the client, okay? You only have access to this little pane right here that we're looking at. This is all you see. You know what? Let's do it even on Chrome. So we'll go to localhost at port 5000. It works. And then when we reach error, look at this. So tell me a few things. 1, what happened? 2, why did the request fail? Can anyone tell me? Just from looking at this. Why did the request fail? Or, so there's no definite answer. We don't know. Nobody knows. I want you to tell me, did the server crash? Yes or no? No? But it looks like it did. Internal server error. It looks like there's an error in the server. Would you know without retrying? Without retrying again, would you be able to tell me?
But even if it came back correctly, you wouldn't know if it subsequently crashed either.
True. You're right. That's a fair point. So, next question. Is the server still up and running? Because it just returned a big server error. You just told me it's overloaded. You're telling me now it's up and running? So what is it? Is it up and running or is it down and crashed? So nobody knows. Is my application still working or do I need to restart it now? Do we need to restart Flask in order for it to work now? No? How do you know? Unknown. Exactly. We kind of have no idea. Nobody knows. Even when you work over here and you work in the company and you're able to see the logs, you also still don't really know. And it's really not enough. You only get a really like maybe 20% of the painting, and even that's a bit blurry. So this is why we need OpenTelemetry. We witnessed firsthand that we need some observability to help us debug and figure out exactly what's happening here. So we'll move on to the manual instrumentation case. If you see over here in our directory over here, in our table of contents, we have a few cases. We started with the base case, and this we finished already. This is just by having a Flask app. Sometimes it works, sometimes it doesn't work, and we don't really know why. We're going to go over 3 main instrumentation cases. The first one is manual. This is by hand we're going to be doing it. The second one is Contrib. And the Contrib contains all of our favorite extensions and libraries and support and automatically instruments all of them for us. And the last one is the coolest, the no-code instrumentation case. Okay, so we're going to be jumping straight into the manual, and let's figure out what it means. So, as it said, it's the hardest but the safest, and you have the most control over exactly what's happening to your application. So I want you to create this file just by copying the Flask base into this file. So we kind of have Flask base in a new file now. You can do it by hand. You can copy all the contents over. So I'm going to be doing Control-C to end this and get out of it, and running that command. Is anyone confused about this part? We're just creating a new file with the same contents. And we're installing our dependencies. Just like we talked about earlier, we're installing directly the API, the SDK, and the exporter that we want. We want the OTLP exporter. So we can copy this directly. pip3 install. Just 3 small little things. Bless you. It'll take a second, but eventually it'll finish. And this is why the manual one is so hard. Because while they don't call it boilerplate, I'll call it boilerplate because it's a lot of code you're just going to have to copy over and over every time. So we'll do this once, and we'll see just how fun it is. It's not so fun. Imagine you were typing all of this by hand, which I've actually done many times. So for the manual, we're going to be closing Flask base. And I want to go into the manual. And I'm going to basically just drop all of this at the very top. And I don't like this import to the bottom, so I'm kind of moving the import at the top. That's it. And that's it. I have a bunch of imports for OpenTelemetry and Flask. I've defined exactly where I'm going to send it to. So, gentlemen in the back, you've said that you need to change this 00 on Windows to localhost, correct? Okay, awesome. Thank you. So everyone on Windows, I'm sorry, you have to change this by yourself to localhost for it to work. But on Linux and Mac, it should work. So we send it to 4317. Can anyone tell me what's at 4317? That's the collector, exactly. Our collector is listening for spans at 4317. It's waiting for something to come in, and then it's going to send it back out. So every service, you can define a name, and if you don't say it's going to be unknown service, we're going to call it my Flask app in production manual. Okay, so every single case we're going to be doing is going to have a different service name, and that way we're going to be able to differentiate at the end. So you first have to create the resource. Then you have to create a trace provider with the same resource. You have to define exactly where you want to export it to. So I'm going to create, and the exporter is tied to the processor as well. So we're going to create one batch span processor that's going to export it to the console. This is our standard output. And we're going to add that processor to our trace provider. We're going to do the exact same thing for the OTA collector, although instead of the exporter to the console, we're going to use OTLP span exporter. This is the exporter for native OpenTelemetry spans, OpenTelemetry Protocol spans at this endpoint that we've just defined, localhost at port 4317. We add that one as well to the provider. We set the trace provider. We finally create the tracer. And so I would definitely define this as boilerplate. And this is definitely not so easy, but you have as much control as you want over the application, and you have choice to do whatever you like. So no, we're not repeating anything actually. The configuration file, you're referring to the OTA collector configuration, right? This is before it even reaches. This is to make sure it reaches the collector. You do all of this to just instrument and generate the spans, and we send it to the collector. From there, it's going to be processing and exporting to our backends. Does that make sense? Yeah, but in this case, where we're setting it, you're right. You're right. It's exactly the case. You have to know exactly what the collector is waiting for, and you have to send that exact same thing. If you send a mismatch, you're going to get an error message. It's going to be some hidden, mysterious message, and only then you're going to figure out, oh, I'm sending the wrong protocol in. It's not accepting, and it's rejecting my spans. That's a great question, actually. Anything else? Okay, perfect. So over there, we create the tracer, and we create the app. And you think, okay, that was a lot of code. Are we at least done? No. We still haven't even created the spans ourselves yet, because this is the manual way. We have to create the spans. So this entire hello world, I'm going to be replacing our function at the bottom with this. And we'll go over exactly what it does. We're going to be saying, at this path, I want to define this function hello. And what it does is, immediately we're going to be creating a span, root, and we use the with one to make sure that we don't have to open and close it. Everything inside of it is just automatically inside of the span. Same as when you're opening a file and so on. So we create a current span, and we give it a name root, because every span has a name. And you can add an event if you'd like. I can just call it root event. You can add anything you'd like there. And finally, you have hello world from our manually instrumented Flask app. And does anyone have any questions with this so far? What does it mean to create our own span, the name, anything else? Okay, everyone's with me. So we're going to be doing the exact same thing for the error message. We're just going to be creating our span and adding an event and so on. So step 9, we're going to test it and run it. I'm going to run this file, the instrumentation manual file. And it's up. And here I'm going to curl my local host at port 5000. And we should see a few things here. One is we got a response. 2, because we sent the exporter in our application to print the logging and to send it to the collector, we see it in our logs over here. Can anyone guess and tell me what this big JSON is, this big document? Does anybody know? Exactly. This is the span. This is what we're looking at. We're looking at the span that just happened. It has the name root, exactly what we did. And it's got a context. So the context is very important to worry about, because this can be very, very hard when you're doing things manually. Basically, every span, like I said, belongs to a bigger family, which is called a trace, right? He could be alone in the family. He could have siblings. He could have parents, and so on. So he has a trace ID, which is almost like the span's last name. And he's got his own unique span ID. This is the span's first name, essentially. It's unique within the trace. Okay? So if he has, for example, children's span and so on, they'll have the same exact trace ID, but different and unique span IDs. Our kind, for example, and so on, our span kind is internal. This is when you don't set your kind, it'll default to internal. And it leaves you kind of mysterious as to what exactly does this mean. And it's because when you do it, you should set the span and you should define everything as well. And that's the problem with doing things manually. Sometimes you don't know exactly 100% what to do and how to fix everything. And that's why sometimes it's best to leave it up to the Contrib and the later versions we'll see. Our parent ID is null, meaning there are no parent spans to this span. And this is the first span in the trace, if there is no parent ID. We got a start time and end time. Our status code is unset. Even though we did return 200, the span does not know anything about it. And the span says that our status code is unset and unknown, basically. Our attributes are empty. And we've got one event, a root event that we created, and at least we got the timestamp of when we did it. And we've got no links, but at least we were able to capture the service name of my Flask app in production manual. The same thing happened over here on this side on the collector. It said, hey, I got an incoming span. I got a traces that was exported to me. And the number of spans that I received was 1. So if we bring this back, and for example, we just send a bunch of spans, we now see over here, number of spans that came in was 6. And the number of spans that came in was 7. And so this is by the batching. It sends in as fast as it can, it sends it out, and it just hopes to not overload the collector with too many. So the collector will, and same for the application as well. The application doesn't want to hold too many spans in its queues. It wants to just get rid of it as fast as it can. So it'll get rid of it, the collector will try to get rid of it as fast as it can, and finally it'll send it to the telemetry backend. So we've got this, and we're able to curl and it works. But what happens if we curl an unknown endpoint? Unknown. Well, we've got this. We've got the 404 here. But do we at least see the span for the 404? That's something I don't know. And we'll have to find out. And what about if I do the error? Will we at least see the error in the span? And so we can come back here. And so we got our successful response with 500. We got an unsuccessful response with 500/error. And it's time to look at the spans. We can open over here. By the way, for Windows users, you have to change this to localhost manually because I put the link in as 000 and it won't work for you, so sorry. You have to go to localhost. So we've got Jaeger over here. And Jaeger looks like this. He's got a cute little animal. And we can define by the service, since we know exactly the name, my Flask app in production manual, we can find traces only for that service. And we can say some have errors. We see that. And some don't have errors, and some won't work. So let's look at ones that didn't have errors. Let's see what we can see. Okay, we've got proto. Our library name is main, and our span kind's internal. I don't know. Not a lot of information. At least we got some logs. Okay, we can see the root event. But does anyone know what just happened in the application? Can anyone tell me? I'm kind of lost too. There's not much information here at all. And that's because it's up to you when you're doing it manually to add all this information. And imagine it would take a lot much more time to make sure that you're capturing every event, every error, you're tagging it, and everything else coming in. And let's look at the ones with errors. So, okay, at least we captured a few more tags. We got that error is true. And we at least captured the error message, that it was 0 division error, division by 0. It didn't really tell us where or when or why, but at least we got some logs. And okay, at least it was able to capture our traceback for us, and we can say, okay, it's probably on line 44 we got this error. And is that the case? It is. So we got something, right? But we don't know everything about the request coming in. We're kind of left in the dark, and we don't really know much. Are there any questions about this, about the manual, where we're looking at the spans here? Okay. So, as we saw, there's not much information here at all. It's kind of looking in the dark, I guess. So that's Jaeger. We can look at Zipkin, and we can say, you can add it by this red thing. You could say, my service name, I want to look at only for spans with my Flask app in production manual. And we can just search for those to begin with. We can see a bunch came in with errors. And, or no, sorry, is that even? Yep, it is. So we see over here, this is our timeline. It's kind of hard to look at. And over here, at least we captured the error. We can say exception escaped false. And then at least we got some sort of traceback, even though it's very, very hard to read. Does it even say the line? Line 44, if you look very, very closely, it's kind of hard to understand what's happening here. At least we got the status code, and at least the status description, but it's not much at all. And on the Prometheus side,
How did you put in the service name so quickly?
the service name? In Zipkin here.
I had to refresh it. Yeah. Once I
Hmm. So you might need to do that. You might need to refresh. But I clicked the red and I went to service name. And yeah, is this what happened to you guys? It auto-completed this? Okay. Does it work after a refresh? Awesome. So good job everyone else. You're doing an amazing job here. Um, any questions on Jaeger or Zipkin about the traces? Yeah. Yeah, I would say they're both not the best in the world, but I would say Jaeger is definitely much better than Zipkin at least. It's also newer, and I think people are still working on it. Anything else? Okay. And on the Prometheus side, if you don't know any Prometheus expressions, you can click this globe over here, and you can ask all sorts of questions. For example, and this is mainly about the physical infrastructure. It's going to be related. So we're not too worried about right now, but for example, the collector process uptime, we can say. And I want to graph that. And so you get this big request, but you're able to graph it, and you see that since time is linear, okay, at least it works. But we can ask questions about the CPU and all sorts of things. So any questions on the manual case? Okay. On a scale of 1 to 10, can you rate how much fun the manual case was? No. Not fun, thumbs down. I would say maybe like a 2 out of 10 at the very best. So thank you. The manual case is very, very hard. A lot of boilerplate, not much fun. And we're about to see what fun is. Step 2, we're going to go on to the Contrib instrumentation case. And we're kind of doing the exact same thing. I want you to take your base, and I want you to just to copy it over to this Contrib file. So we're going to just be building on top of the same code that we know. And so I'll do this. And so I'll copy the file over. I'll pip install only this one thing. And this is the instrumentation for the Contrib. OpenTelemetry instrumentation Flask. Okay, so all of your favorite third-party tools and libraries, they all have instrumentations in the Contrib repository, and you can just install them, and it works just like magic. So let's paste that in. And I'm sorry about the boilerplate in this one. I guess it is possible with environment variables, but it is better to do it this way, just one time. So, oh, and also for Windows users, this is a place to watch out and change this to localhost. So I'll close our manual, and I'll go to the Contrib, and I'll add the boilerplate at the top again. But what it's doing is it's saying, I want to import the same exact things, but additionally, the Flask instrumenter, just one class. And then I'm going to set these two environment variables equal to essentially true in a way you could think of it, but it's regex, so we'll get into that. So what it says is, for my OTel instrumentation, for every HTTP call, I want you to capture the headers of the server request and the server response. And it's going to be set true to whatever matches with the regex. And so we say dot star, it captures everything. Okay, any questions on this? Okay, perfect. We're going to say on the endpoint, we're going to be sending it to the collector again, 4317, but this time with a different service name, my Flask app in production Contrib. So that way we have differentiating, we're able to see which spans are better and worse. Same exact thing, we're going to be sending it to standard output as well as the collector over here, right? Nothing new. And then you say, okay, what else is there? Only one line. After you create your application, you go into the Flask instrumenter and you say, take this application and instrument it for me. So you go over here, and boom, this is all the work. We don't touch anything else. Your code remains the same. So imagine you can write your code and you can just even have the boilerplate on a different file, and you can just import everything else and it'll work. So let's test it out. By the way, any questions so far on this and what we did over here? The idea? Okay, perfect. So let's run a Contrib file. we're running the Contrib, and we can curl our localhost at 5,000. Now I want this to print over here as well as over here. And look at this. This is a much bigger span than what we just did. It's even captured the exact path that we just did. So it captured the path. It's captured the fact that it's a server as well. It was able to, well, it didn't set the status code yet, but it did capture everything else about the request. It got the get. It got the fact that we went to 000. It got the fact it was HTTP. It got the port. And it got pretty much everything else, as well as the headers. Would you believe it? It even captured the status code. Could you repeat that? At the top here? I'm actually not sure. We can get into that. That's interesting. That's a good one. But as you see, it was captured over here. So I'm sure there's a way that we could do that. And it got our service name as well. And over here, we say that we got one span come into the collector, and so on. And so we can do the same thing. We can ping an unknown endpoint. We can do it a bunch. Just be careful not to DDoS your own computer. And from there, we'll do the error. And I want to spam it with errors as well. And we see 6 spans came in, 10 spans came in, 13, and so on. And we can go back over here. We did a successful, we did an unsuccessful, and it's time to check what happened. We'll go back into Jaeger. And same thing over here as you experienced, sir. We do need to refresh in some cases. And boom, we got a new service come in. And we now have 2 services, the manual and the Contrib. So let's check out the Contrib one. And we'll find traces. And you'll see you can even change it by operation you can check. You can check by the traces that came into slash, the traces that came into error, and a get that we made as well. So let's see what it looks like without an error. And this is a get. Let's see. Interesting. So that's good. Okay. So even now I'm learning something on the spot now. So whatever we made to slash was sent to slash and it returned a successful response. Okay? And we're able to see everything that came in. We got the fact that it was in a get to localhost 5000. We got all of our headers, the accept, host, user agent, everything else. We got the status code, and so on. We're even able to say the fact that it's OpenTelemetry with this Flask instrumentation at this exact version, and so on. And everything that came in to slash error was an error, but at least the trace was sent to the collector, and we got the trace. And it captures a little bit more information. It tells us the fact that there's an error. The same exact things about the request and the response. We got at least the error message. But here in our logs, if we go, we did get the full traceback as well. So we got the full traceback for the error. We got all of the headers as well. And I think body is something that's coming up soon. In fact, we're able to also collect the entire body. And, yeah, go ahead. It should look pretty much the same, but we can feel free to test it. And I think from Unicorn, whatever is instrumented. Wherever the instrumentation is where it's going to send, is exactly what's going to send it to the collector. And from there, it'll be sent over here. So I just want to pause for a second, and I want to see if anyone has any questions, anything else. But I also want us to appreciate the fact that we just did all of this. You guys did it, not me. You guys did it yourselves. You guys ran all of this. You co-hosted it on your own computer. And good job, everyone. It's not easy. And you did an amazing thing. This is much more than you guys realize. And it's a big deal. So, good job to everyone. And so we just looked at a few spans over here. And so we looked at slash. We looked at slash error. And everything that came in that wasn't a defined endpoint, it's just defined as HTTP GET by default. And we can look at that. And so these are the 404s that we did to slash unknown. We see the fact that it went to slash unknown. It was a 404. So we can't say exactly what target it was because it's an unknown target. We don't know what slash unknown is. It's just a get, we'll call it. But it captures everything else the same. Okay, on a scale of 1 to 10, how much fun was the Contrib instrumentation? Slightly better. Okay, maybe a 5. Yeah.
So if you, so this is instrumenting Flask, but if you're running like philosophy or some database queries in the backend, do you have to instrument those separately, or will this? I'm assuming the answer is yes. But
For the Contrib version? Yeah, what was that?
so how do they play together when you instrument like different packages all at the same time?
Yeah, it works very well together. This is the purpose, not to disrupt anything. So the whole point of monkey patching and wrapping all of your code is that if anything breaks down, it's OpenTelemetry that's breaking down. We don't want to break your application. We want everything to run as smoothly and as possible as it can. And so if something's going to fail, it's going to be OpenTelemetry, and at least maybe you won't get a trace, but at least your application will still be working. So if you want to do, for example, we'll be over here a Flask instrumenter. And say, for example, you're using also Mongo and Redis and all these databases and anything else. Same exact thing. It's one line to import, and then only one line just to instrument. For the Contrib way. For the Contrib way, you do have to import and also initialize the class. Yeah?
So if I wanted to instrument like another service like Redis or something that calls for server, that's probably more appropriate.
Yeah.
Would I get child spans based upon your class cap?
Yeah.
To get information about my service monitor?
Exactly. This is the whole point of distributed trace. That's an amazing question. We won't get too deep into that just yet. Maybe if we have time at the end, we can go into that. But that's an amazing question. That's the whole point, is that every service should ideally be requested, should ideally be instrumented, and that way you can see the distributed trace. Start from here, start from your application, go to Redis, go to Flask, go to anything else, and so on. So yeah, that's exactly it. This is the whole point, is that you can use eBPF for if everything's running on the same computer, but it's a bit harder once everything in a distributed environment. Any other questions? Yeah?
Is there a recommendation on the amount of spans you should send at like in one trace, like one parent transaction has, I don't know, 5,000 spans? Is that absurd?
So, great question. It's ideally as many spans as you can get, right? If you can have 3,000, yeah, why not? But I've actually seen a few, even commercial limitations, where it's just too big. The request coming in is way too big to handle. And so, yeah, we do need to do better work to keep up on that. And so, I was actually at a different commercial offering for something like this, and we actually told the customer, like, hey, way too many spans for the trace. Like, it's just impossible to keep up with. So, but yeah, ideally as many as you can have, because really it's just a story of how a request propagates through your system. And if your system is huge and it has all these components, you wouldn't want to be missing a piece, right? Yeah?
Flask API that takes like an hour for a return response. Granted, that's horrible design. Do you get information about in-flight requests, or does it only publish them to telemetry on returns one way or the other?
What do you mean in-flight requests?
Like, let's say for some reason you have allocate a terabyte of data and download all of YouTube to it and then delete it, and that's one request. Can you see how many of those are in flight while they're in flight, or do you have to wait for them to fail or succeed before they show up in telemetry with the trip graph?
I haven't tried it, but I think currently for OpenTelemetry, you have to wait for something to finish, and then you'll see it. I think that is the case. It has to wait for it to fail or succeed, and then. Yeah.
Like with it, the spans are sent by each service, and they're combined by the collector, so you would see the in-flight stuff, and if you hit refresh, more data will start showing up.
That's exactly the case. That's the whole point. Since each one is distributed, that's exactly what you said over here. So say you have an application that pings this one with requests. This one goes to requests. This is the Flask, and then it goes even up to Redis, for example. Each one would send a different span to the collector, and it's up to the collector to piece all of it together and to put into a unified trace.
So you would only send each of those spans when each layer is done.
Exactly.
So like if you had the first call, the second call, the third, when the third one finishes, it sends a span, and then when the second one finishes after that, it sends a span, and the first one finally finishes because the file brings it back. That's when the spans come in.
True. True. Exactly. So also the case is that it's kind of a race condition. If you check, for example, the auto collector or your telemetry backend, when this one's finished but this one hasn't, or vice versa, then you could see an incomplete trace, of course, because the span just hasn't come in yet. These are excellent questions. Any more? Yeah?
So you can see the latency on the request in Jaeger. Can you extract metrics from those? Like, I want to know how many requests took over like 7 seconds or something.
Oh, definitely. We can do this with Jaeger. And we could say, for example, max duration and min duration as well. We can do this also with Zipkin as well. And you could say, for this service, I want to see things with max duration or min duration as well.
I guess what I would be getting at is like I would want to be alerted if some number of requests took X number of seconds. And I don't think Jaeger can do that, so we'd have to forward the metrics to another place that could alert. Is there any way that OpenTelemetry kind of gathers those types of metrics to put in like a time series database or anything?
Yeah. Well, everything is sent to Prometheus as well, which is a time series database. But I don't know if what you're saying about having an alert and things like that, I don't know if it's possible with these vendor neutral options. You might have to go to a commercial option. Yeah?
OpenTelemetry is designed to send to a lot of commercial options too, so you can just basically send it to Elasticsearch or wherever you are storing your stuff, and most of those places support that. That's another option too. Like you don't have to use Jaeger. You can use Elasticsearch. You can use lots of other things.
Exactly. Yeah.
Question about the Contrib, the automatic instrumentation for streaming responses, like where you're dynamically generating responses and you're sending each chunk responses, or you're getting file uploads and they're streaming up. How does that go with the default? Because I imagine if you were coding it yourself, you get control of the rest of them.
That's an excellent question. So these are excellent questions, guys. I've actually never even tested downloading something huge and having it traced with OpenTelemetry. We can test it at the very end if we have time. That sounds excellent.
That's what you could, it was more of a, are you giving up that granularity when you use the Contrib auto instrumentation, or does it cover all of them? Like, are you building on intermediate beginners, or are you building on experts for the Contrib stuff?
Both. I'm sure there's a way. I'm sure there's a way to do it. It's designed to be as flexible as you want. So we can get into that. That's very, very interesting. Anything else? Okay.
I guess on that point, the question that I would have is, with the automated instrumentation, Flask instrumented, how would you get access to generate spans?
To generate child spans? You still have all the flexibility of the manual way.
Oh, you still have
We still have the trace provider. We can create the tracer, and we could still do create span here inside. So, yeah, the Flask instrumenter, although it makes things easier, we didn't give up anything to be able to use it. We can use everything in parallel and have both. Does that make sense? Yeah?
So I think what he's getting at, like if you wanted to get more fine-grained inside there, like let's say you're calling into your database, and because you're only using the Flask instrumenter, it doesn't know about calling into Redis or calling into whatever AWS calls theirs. You might want to say, hey, by the way, like for this block of code, I'm calling out some service, and I'm trying to tell you a little bit.
Exactly.
Like you don't have access to the context information to pass your tracer, if I understand this correctly. Like it's not giving you a magical reference.
It's not giving you at the end?
Like how would you reference or tell, OpenTelemetry, this new information I'm passing you is associated with
That's an excellent question. So we still have the trace provider, right? We have to keep this in mind. Basically, when a request comes in, its entry point will be this hello function. Do you agree? And so everything inside of here will be inside of the Flask instrumentation. But from here, if we say, for example, it won't be exactly this, but it'll be like tracer.startSpan. And we do like width, for example. And we do whatever code we want in here. This code will be inside of this new span. You can call this, for example, Redis. By the way, there is a Redis instrumenter and everything else, and also AWS and everything else. But let's say there's something that we don't have an instrumenter for. We could create a span inside here, but it's important to keep in mind, this is a brand new span with its brand new information. It's completely blank, but it is a child span of this span over here, the hello and this slash. So this is the hierarchy, that you don't, it wouldn't be a parallel. One is clearly the parent of another. Yeah, amazing question, guys. Any more? Okay, amazing. We're actually nearing the end, guys. So, and I'm guessing this table over here pretty much finished, right?
I would like to see Prometheus. I mean, what's with this latest thing? You showed something briefly before. I just went by so fast.
Yeah. Only because Prometheus, it wouldn't capture every much thing about the trace, per se. We could convert the traces to metrics, but that would take quite a bit of effort here. So what it really contains is mostly about the physical architecture and the physical infrastructure of the auto collector. So for example, we can look at the queue size and the queue capacity. We can look at how many spans were sent. We can look at, yeah?
I'm sorry. How do you even pull those down? How did you get those lists?
Oh, so over here, I have my bar, and so it's the globe here on the right side. And so you can look very deep into the physical architecture that's running the collector. For our purposes, it's not so exciting because we're mostly interested about traces, right? Yeah, exactly. You could do just that and then send them into Prometheus. I've seen that happen before, yeah. Of course, the request contains everything about the start time and end time and the duration itself. So of course, you don't have to pull everything at once. You could group it however you'd like it. Does that answer your question? Yeah. Okay. Anything else? Do you guys want me to go more into Prometheus? I mean, this is pretty much it. Okay. We can see exactly some pretty cool things. For example, the collector, how long has the process been up? We can execute that one. And we can see it's been up for over 3,000 seconds. So good job, guys.
Because it's time series, it's just monotonically.
Yeah, yeah, exactly. But as we have it right now, there's not so much interesting information here. That's the only issue. I think you would have to convert the spans to metrics first to do that. It's quite a process, though. With OpenTelemetry? In Prometheus, of course. So we can look at it. I think now we can look at it. So the response time? Yeah, we can look at that soon. But the exporter, queue capacity, queue size, so sent spans, for example, we can look at. Empty, I guess. Oh. And so we've sent 58 spans, for example. We can see how many failed. by failed spans or failed requests. And if we execute this one, we have, it says 0, but I don't know about that. Yeah, of course. Once I just don't believe that the path was sent in over here. Yeah, it wasn't. But once the path, for example, we send the trace, we convert the trace to a metric and do that, of course we could do that. And this is the query language. This is promql here at the bottom, for whoever doesn't know it. You say, this is the metric I'm curious about. And then here's how you define basically filters. You say, but I want this specific instance. I want you to look at this specific job and this service instance ID. For example, this service. So that's the only thing, that we've pointed Prometheus only at the collector, not at the application. Yeah?
Converting the traces to metrics, is that all automated anywhere, or is that all ad hoc coding by the application developer? Every particular one?
Yeah, I'm not sure about the details, but I think it's definitely automated. I just haven't seen it firsthand. Yeah?
So at the beginning, someone asked whether or not OpenTelemetry supported sampling as opposed to just all the tracing every request. How do you configure that?
Yeah. I mean, let's see. I did see that it was released pretty recently, the head-tail sampling. So let's see. We have OpenTelemetry. We're going to Google it together, guys. And we're going to see what's new. Because things come out every day. This is the cool thing. This was released in March of 2020. So let's see. Over here. I don't know. Let's see, guys. Doesn't say here, but let's continue at the end. Yeah?
So, what's the process uptime coming from? Is that some sort of heartbeating that's happening between the collector and the Prometheus?
It's
Collector?
pro-
What's uptime?
it's just how long the process has been up and how long it's been running.
So that's the Flask process's uptime.
No. This is what's important, the collector. Because if you look over here in our collector demo, Prometheus YAML, we've pointed Prometheus only at the collector. So
So that doesn't necessarily tell us if the app is up or down. It tells us that the collector's up or down.
correct. We'd have to point this to the application. But for now, it's pointed only at the collector, so we're looking only at the collector for metrics.
And so in response to your question right at the start, like, how do I tell if my app is broken, needs to be restarted, what would your go-to metrics be, or your go-to, given the tools that you've shown us and that we've implemented now, how do you answer that question?
Yeah, that's exactly it. I would send the metrics to the collector as well. It's just a bit more, so
So
yeah.
given everything that's set up, how do you answer the question, what's wrong? You've got an error page.
Yeah.
You've got all these metrics and apps. Which one do you look at?
My go-to is always traces, number one. I jump to Jaeger, but that's the thing, that if Jaeger says there hasn't been any traces for the last hour, then I would resort to this. That's why it's kind of more of a backup. But traces are really number one.
And so traces, because right at the start, one of the suggestions was I'd hit it a few more times to see if you get a mixture of successes and failures. So traces is kind of depending on that happening. Traces is depending on a bunch of people hitting it so that you get some successes and some failures to look at, right?
That's true, but sometimes traces are generated without you getting a response back. It could be that one's working and one's not. So it's not a definite yes or no.
So if you've got user activity, you should get some traces to look at.
Exactly.
Okay.
Yeah, at least they'll get something. You're able to see, oh, it's an error right there. Even if the user sees like page destroyed, there's no application, you'll probably still get traces. But yeah, traces number one, and then metrics as a resort, and then logs finally if there's nothing.
So if I open up Zipkin and I see that
Exactly. Yeah. Yeah. Yeah, that's exactly what we do. We would go over here and yeah. It looks a bit hard to do in these. Um, oh, over here. I would do error equals true. Sorry guys, I'm not too familiar with these. I'm more familiar with a few commercial options, so I've tried to remain vendor neutral today and stay open source. But over here we do error equals true. You would look at what came up, and let's say it was a couple minutes ago, you say, oh, I got a trace right there. And what's the error? At least you have an idea now of what happened. And then also, if you're also capturing user data, you could see, you would have, for example, user.email, for example, or user.username. Oh, this is exactly the user that was affected by this error and this and that. And so at least you have some context as to not just, oh, it broke, but it broke for this user when he clicked this button. Oh, yep. So over here in tags, I just said error equal to true. And let's see how helpful this question mark is. Yeah, so we can do a few things. And I saw a question over here. We'll start with the one on the right. Yeah, right now. Sorry. I just got a bit distracted.
And I was going to point out too, we should probably like, I don't know, add a request.get or something inside of our functions. We can at least see like, nobody's even seen a waterfall of more than one span, right? Like it'd be fun to like show.
Sure, yeah, let's do that. Let's do that right now. Let's actually do it in the no code. That'll be pretty fun. Okay, so any more questions before the no code? Okay, perfect. So the first one, the manual way, that was not so much fun. It was a 1 or a 2 out of 10 at most, right? By your definition, not by mine. And the contrib was a bit better. At least it was at least 4 or 5. At least we got some more information, but it was still defined, still needed some boilerplate. And so let's go over here. We'll come back. And we're ready for step 14, the no code instrumentation. Now this could be a bit heavy on your computer. It could take some time to download everything. But you're going to need to pip install this OpenTelemetry distro package. We've installed it. And then we just need to run this command. What this does, OpenTelemetry distro, when you install it, it installs a CLI command called OpenTelemetry bootstrap. And when you run it with install, I believe -a means all, to install all of them. And this could take a few seconds or maybe even a minute in your computer. It'll install all of the Contrib instrumentations manually, or automatically meaning. So URL lib3, we got request earlier, we got everything else. So OpenTelemetry instrumentation request. So exactly, so we'll do this in the no code, we'll get the waterfall, and yeah, an excellent question by the way about the waterfall. We got gRPC, and is everyone here, is anyone waiting for this to finish? Okay, perfect. Let's move on. Step 15. And so we got this long command. And so when you install this bootstrap and you do install, I believe also I believe it's here actually at this stage. When you do pip install OpenTelemetry distro, it installs two main CLI tools. One is OpenTelemetry bootstrap, and one is OpenTelemetry instrument. OpenTelemetry instrument is for Python. You can basically wrap your Python command with OpenTelemetry instrument and have the benefits of the contrib, but without touching anything in the source code. So what we're doing here is we're doing OpenTelemetry instrument, and we're defining our trace exporter. I want to send it exactly like we did earlier. I want to send it OTLP, and I want to send it to my console as well and print it out. I'm going to define my service name, and I want it to be my Flask in production auto. So this is a new one. So we can see a brand new service. And I'm going to define exactly where we're going to send it to for my OTLP endpoint. And that's going to be localhost 4317, right? I believe this is already suitable for Windows users, right? Because it's already localhost. And then we also attach the base. So we're not running Python 3 separately. This is part of the same command. We're saying, and this is the command that I use to run Python. And this is the file that I'm going to be running. So it's part of the exact same command. So our traces exporter, my service name, my exporter OTLP endpoint, and Python 3 flask.base.py. So we'll first run it normally, and then we'll add like request or something. We'll make a request, and we can see the waterfall. So basically, copy this whole thing. Does anyone have any questions about anything here, about the big command? You agree it's kind of the same as what we just did? We're just defining exactly where to send it to, what we want to send. Yeah?
This OpenTelemetry instrument, can you run it with other things other than just Python?
That's a good question.
Python, but like there's other programming languages out there.
That's actually a great question. I had the exact same one until I realized that, oh, it's by pip3 install. So there could be, but not for, because it's for pip install, it'll contain only the Python relevant stuff. And we'll start with the,
Can you use environment variables instead of like dash dash stuff?
of course, yeah. You can use environment. So it could be even more simpler. Even simpler. And sorry, we'll just take the one in the back first.
You also have to make sure that you install the OpenTelemetry exportable DLP for this command. I have to rebuild my VM, and when I run the phone command, they're all saying that the OpenTelemetry exportable DLP was installed.
Mm.
It works if you code into a thing, but if they get standalone on the project, so that it's
Okay. I thought it would be part of this bootstrap and this distro, but if it's not, okay, then I'm sorry, but you should already have it from when we did it over here.
Yeah, I have to rebuild my VM and doing the debug.
Okay. So good to hear it worked. Good job. And over here in the front?
If your Python app launches other Python apps, instead of importing them and launching them in process, does it follow that? Or if you use subprocess to launch multiple child subprocesses, does it follow that?
You're saying if you're doing OpenTelemetry instrument on a Python file, and this file internally calls subprocess and it runs Python 3, run this file.
Yep.
I believe you would have to change the subprocess command inside. You'd have to say OpenTelemetry instrument Python 3.
What if you're using import subprocess for parallelism?
I don't believe it wraps that call.
So I actually know the answer to this.
Oh, okay.
I happen to because I'm playing with this personally, but it does this via Python path environment variable stuff, so it actually should cascade down through because that Python path will still be set.
So you might be able to like have something that launches the shell script that launches Python.
And it should. It's possible if you have path, if you're messing with paths in the middle, then it might not. It's pretty cool. If you want to know how it works, you can come ask me afterwards because I've been playing around with this for our Elastic stuff, and it's pretty cool stuff.
That's amazing. I might come and ask you.
Or I can come help after. It's cool.
Anything else? Anyone else? Okay. Guys, you're asking some amazing questions. I'm really, really proud. Okay. So we have this big command. We'll copy this command, and we'll put it into a file named Flask instrumentation nocode.sh. So I'm going to just copy this, because I'd like to create files with touch, just to make sure it's there. So I'll touch, and I'll create this no-code file. I'll paste this big command in there. Over here. So we'll go over here to nocode.sh, and we print it. So you could go like this, just to make it more readable. Maybe this is the better idea. But we'll just leave it as is for now. So, oh, I like to do chmod. Does anyone not know what chmod is? Okay, amazing. Can anyone tell me what chmod is if you're also knowledgeable about this? What does this line do? Okay, you got it. Good job. Okay, and then we're just going to run this file as an executable, like you guys said. And so what we did is we're running our Flask base.py. We're running this exact same file that we looked at earlier that has no instrumentation. It's just basically a print hello world. It could be anything else. But the fact that we're using Flask and this has instrumentation for Flask, then we should see something cool out of it. Now over here, if I curl localhost 5000, then I want to see a print here because I am printing to the console, and I got it. And I want to see the span come in as well, and we got it. So now if we span this a little bit, and we do error as well, so now if I come back to Jaeger, and you see it doesn't show up here, I do need to refresh. So I'll refresh, and now the auto does show up. So now we have our three main ways of instrumenting: the manual, the contrib, and the no code or the auto way. So I'm kind of look for traces, and okay, we still have error equals true. That doesn't affect us in any way. So we'll look at this one with an error. And now we can see we've actually captured a little bit of information. That's pretty good. We've captured the fact that it's an HTTP call to this. We didn't capture the headers, but this is the environment variable. We could just set that one. Let's actually take this from the contrib. So let's take this one. And so if I put it in front of this equals dot star. And can anyone tell me how do you do multiple? You could just do space and just do the same thing again? Okay, awesome. So I'll do this one as well. So capture the request and capture the response equals dot star. And then our command. Right? So any quotes? Makes sense. And let's run it. We'll get the error one. And let's see. So I want to see in Flask this exact same thing, but with also the everything about the headers in the request and the response. So we'll find more traces. When did this one come in? A few seconds ago is good enough. And boom, we got it. So this is quite a few bits of information. It's not bad. It's more than nothing, would you agree? We contain something about the process. So this might seem trivial to you that we collected today, but back in open tracing and open census and a few older protocols before OpenTelemetry, this wasn't always collected, and it became quite a pain to figure out exactly which version the user was using and what language exactly. And so now it's just sent in the trace, right, and just make things easier. Is that a question in the back? Okay. And we collect also in the log as well, everything about the exception. Everything you'd see in Python is on the computer, as if you're on the computer itself. And yeah, any question about this? Go ahead. You would use something like auto, yeah. Let's see. I actually have no experience with Unicorn personally. I haven't used it. 8 threads or 8 processes? Okay. So let's see. OpenTelemetry Unicorn. And working with fork processes. So this is something they've actually taken care of. It is possible. But personally, I've never worked with Unicorn before. Oh, if we're saying for the contrib way, let's see. Yeah. Contrib and auto are the same thing. Pretty much. This is kind of like a modified contrib. And okay, so let's do what you guys said. Let's do our request. So I'm going to make sure. I'm going to pip3 install request. Now that we have request, I'm going to be. So I want you guys to tell me. If I do over here, request.get, who's the parent span? Flask or request? Flask, of course, because it enters Flask. And then inside of that, you have the request. So the request, I expect it to be the child span. So we're going to be making a request to Google. And we can do that, and we can print the status code. Okay, let's do this. So I'll run the no code way. And because it's only in this one, so we'll do without the error. We'll do this. It didn't. Oh, it should print over here, right? So let's see. And so we see two spans here. This is the Flask that finished, and this is the request. Or this is the this is the request that we made from the client. Yep, 200. So exactly what you said. Because the Flask is kind of wrapping around it, it's before and after the request. The HTTP request that we made to Google finished first, printed first, and then only when this one finished, the outside, basically the parent of it, then we get to see this. But usually it's not like that. Usually in a case of a distributed environment, let's say for example it's a bunch of ECS tasks or a bunch of lambdas, when the first one finishes and he invokes this one, he'll just send the span out. He's not always waiting for a response. It could be an asynchronous push. So it could be that you'll see the parent come in first and then the child. But in our case, it's the opposite. We'll see in the time that it comes in the collector, it's first the child comes in and then the parent comes in.
Why would you see the parent first in that case? Is it just timing? Because it's distributed, you don't need to run.
Yeah, it's just like a race condition. So let's see. I expect to see over here. Let's take out there is true. And that's exactly it. We have our waterfall exactly as you wanted it. And we have over here. So basically this is the parent span. Someone made a request to our server. We returned the 200. And it was Flask. And then if we close this one, our child span inside. And you can clearly see the hierarchy as, you can collapse this and this is inside. And let's see what we did. We made a request to google.com with our auto instrumentation for requests. It returned the 200 and we're a client. Any questions on this?
I have a general question. Suppose you have everything instrumented, but you don't have the infrastructure turned on. Like you run your application, and it wants to connect, but it's obviously not successful. Is your application still going to work, or is it going to hang?
You're saying if your application is trying to send span somewhere, and this person is not willing to accept it. There's just no one to talk to. The collector, basically. Yeah. So like I said earlier, your application will work, of course. Because OpenTelemetry and every single instrumentation framework out there, their number one goal is not to touch and mess up your code. Because this could be a real production thing. There could be billions of dollars at stake. We don't want to touch and ruin anything. So worst case scenario, your code is still running, but you might not have a span to look at it. Right? But we want to keep your code running and ideally also have a span to look at. So I've done it before. You would get eventually maybe like a warning log or something like that at the worst case, but that's it. It wouldn't hang and it wouldn't destroy anything in your application.
I was doing that accidentally earlier. I gave a bunch of retries. It did about 5 or 6 retries with a second between them. So it's taking a piece like this to do that. But otherwise, yeah, it was a lot.
Is it rented out, interesting rented version of that? If you misconfigured your firewall and the tracers or the collectors are just straight up dropped, then what happens? HTTP request succeeds. You'll get a rejection back. But it's never going to respond. Like it's async or if it's threaded out, then I would just be none the wiser to keep wasting resources. But I'm curious as to whether it would without hang instead.
Yeah. These are excellent questions, guys. This is amazing. But essentially, yeah, if you do have a firewall, you do need to make sure that connections are allowed to go in and out and make everything work. And yes, question in the back?
So when we did the bootstrap earlier with the -a install,
Mm-hmm.
I noticed it didn't install everything it could have as far as implementation. Like we didn't get C block, we didn't get a bunch of other stuff. Did it look at the packages in the virtual environment and only install them? He's nodding. It looked at the packages you have installed and it only installed the instrumentation that was relevant.
Oh, really? I didn't know that. Is that the case?
I mean, it obviously had requests because you didn't have to run it again. So like it didn't install everything, but install, I don't know. It must be looking at it something because yeah, it didn't. That installs last for you or whatever, but like,
Yeah. So it could be the case, but in case it doesn't work and it doesn't install what you want, like I said earlier, the no code is just really a more advanced and basically Contrib way. So you could just install whatever instrumentation package you need. For example, you could install this, and the no code would work. Yes, question?
So what would be your recommended way to do distributed tracing across a microservice architecture where you've got 5, 6 different services calling downstream, trying to get them all wrapped into a single trace?
Yeah. Yeah.
How would you do that?
Well, that's an excellent question. It depends actually very specifically about which microservice you're using. That's the thing. So, for example, I've seen for Kubernetes, OpenTelemetry. You could do a sidecar, you could do an operator, and you have a lot of really cool ways. You could do it straight with Kubernetes. You could do it through Envoy, that they create the spans for you. But let's say you're on Kubernetes, you'll have automatically generated spans. You just define exactly where to send it to this collector, and so on. For example, for Lambda, AWS actually has their own distribution of OpenTelemetry. You just add it as a layer to your Lambda, and it'll automatically make sure that spans are sent out to the collector, and so on. Let's say it's a containerized application. You could do something in the base image to just instrument all our applications, and then everything that you're writing in the top image, that's all your custom code, then it's automatically instrumented already. Yeah?
It all happens through HTTP headers too. So like that request thing.
So the reason why I'm asking is because I was trying to do just that, to use the trace ID formatted header, and it wasn't actually generating the proper span. So what I ended up having to do was something more like your manual method, and actually generate the span objects myself because they weren't picking it up. And I don't know if it was just I had a problem with how I was setting it up. But the tooling just out of the box wasn't
Yeah. For which microservice?
well, it sort of doesn't really matter.
Yeah.
I was building the standard. The point, I guess, is just using the width wasn't able to pick up even. There wasn't a good API for me to inject the parent span information.
Oh, yeah, yeah. If you're doing it manually with the width, then you really have to worry about, so let's do OpenTelemetry, let's say Python manual. You have to worry about something that's called the context and the baggage. And so, yeah, this gets really, really complicated. This is why I hate using the manual way, and pretty much everyone else does. I want to say a good example of context, but let's see. And yeah, question in the front here?
Yeah, I was wondering about security. Is there a way to set up like a shared secret between the source and the destination to make sure that you don't inadvertently connect to the wrong collector?
Yeah. I believe you could use any secrets manager, any vault manager for something like that. I think OpenTelemetry is trying to stay out of something like that.
Yeah, I'm in an academic department or a situation where we might have multiple different students all on the same host. And we also have multiple students having their websites, but they don't get to see the combined logs because they didn't see everybody else's. And I was imagining, what if a student wanted to set up OpenTelemetry to see just the results of their website, but then they turned it off or forgot about it, and somebody else came along and used the same port number. Now the wrong website is posting data to a different telemetry. And I was just wondering if there was a way to set up like a shared secret or something so that only you couldn't send from the wrong one to the wrong one.
Oh, actually, yeah, definitely. Sorry. There are definitely things like that. And let me find you exactly. So we use, actually, at my company, we use something very similar called an OAuth 2 extension. An extension for the OpenTelemetry collector. Sorry, my spelling's terrible. But essentially, you have to combine, you have to say a few secrets. You have the client ID and the client secret, and you have to have some token URL and things like that. So, for example, in our production environment, you have to set up the collector and for the exporter. You have to set it on both for it to work. And so only this person can send it these exact spans to this location. And so I can share with you a name, but it's really the OAuth 2 client. Yeah.
Random related question, is the default, like, don't do anything but run the injector, the zero code, is that GPDR safe, or are you creating a problem in production?
Is that one?
GPDR safe?
I've never heard of this.
Is it going to collect any user identifiable data by default?
What is GPDR?
It's the European,
Oh.
we have to click on all the things, I don't care about cookies.
So most of these don't, I don't know. So we have APM clients at Elastic as well, and we really work hard not to collect API unless you explicitly tell us to. So it's just going to collect timing data. It's not, that's why you had to do the header thing, right? Like, it doesn't collect headers by default because that might be API.
Yeah. Well, thank you. Thank you so much. I know nothing about GPDR. You can keep going, yeah.
PII is you don't want it in your Jaeger thing anyway, right? In general, so.
Yeah, like expunging user data from this would be a pain in the royal.
Yeah. Anything else? Okay. Does this make sense? The OAuth 2 client?
I think so. Where is it in here? OAuth 2 client.
Oh, so I'm over here on the collector Contrib. And so yeah, it's defined as an extension in the collector. So basically there's the collector, and then there's a collector Contrib version as well. And this contains same exact thing as what we just talked about, all of the extensions and everything else. And so the collector Contrib contains much more than the collector itself. And there should be a table here. I remember seeing a table, but it was somewhere. Not sure. But yeah, if you go over here to extension, you get the full list of all your extensions. Oh, so over here, so Jaeger remote sampling you could do for whoever asked about sampling. You have your OAuth 2 client extension as well. But you do have a couple other. You have basic auth token, bear token. And so you don't have to use the OAuth 2. That's a bit more complicated. You could use a couple of simpler ones, such as these two over here. You could use ASAP auth extension. But yeah, I would use probably something similar, probably something easier if the students are doing it themselves. Yeah?
Do you have any suggestions or recommendations for deciding on your sampling rate?
I wouldn't do something too high. I would say you would want most of your traces, but I would say maybe you could cut out. You could do something like, I want to keep only 5% of my traces or something. But the main thing that I would focus on is, if there is an error in this trace, don't sample it, right? I want this trace. So that's the main thing to keep in mind. And so when you're doing sampling, and I'm not too familiar with the sampling because it's pretty new, but this is the main thing to keep in mind. If there's an error, you don't want it sampled. You want it there. And then from there, you can pick your own. You could say 10 or 20%. But I think ideally, you would have all of your traces, because each one tells a different story, and you don't know how it might come up in the future that you might need it.
Related to that, is there a way to age off traces?
To age off traces.
Select them all, but just start statistically removing them after a day or after an hour.
So a funny story.
If you're fiercely diving on an issue, you get everything a whole take as much as your disk can hold tomorrow. If you forget to delete them, it starts just auto-purging after a while.
Yeah, exactly. At my previous company, we had just too many traces in our database. It was just too much. Everything was going crazy. So we decided to have a policy that after 7 days, your trace would be gone, and we would delete it. And you could pay for extra if you wanted, but every 7 days, or after 7 days, the trace would disappear, because obviously the issue is not relevant anymore. But it also became a nice premium enterprise feature. Question in the back? I think there's both now. There's head-tail and tail-based. There's head-based, and tail-based sampling as well. So you could do an application side, and I think now they just added on the collector side, or vice versa. You could do it on both. And anything else? Okay, we're nearing the end, guys. I don't want to hold you too long. We are going to go soon. Does anyone know when the break is? Maybe we'll finish even before the break, and I'll let you out for the second half. You could stay as long as you like, but I want you guys to now answer a few questions for me. And so we'll scroll here all the way to the bottom. Step 16, we're done, right? And I want you to answer me. I want someone to tell me here, what is observability? What is it? Nobody knows? Almost. These are the 3 pillars of observability. That was good. Can someone give me a, okay, that's actually great, but can someone give me a generic and a very basic definition?
Ability to understand an application from signals that it gives.
Exactly. Exactly. You're watching something from the outside, and you're able to, just with a tiny bit of information, become smarter and smarter and make better and educated guesses about what's happening inside. Okay? Can anyone tell me what is OpenTelemetry? Feel free to shout it out. It's okay. Yeah, yeah, pretty much. It's a protocol that creates spans and sends them and eventually stores them somewhere. And can anyone tell me what observability tools exist? 3 main ones that we've used today. Amazing. Good job, guys. And can someone tell me what methods can I use to instrument my app with applications, with OpenTelemetry? And? Awesome. Good job. But when should you use each? What's the advantages of using each one? For example, the manual one. Why would I ever use that one? Yeah. Exactly. Both answers are correct. Good job, guys. And so why would you then use the Contrib one or the auto one? Is there a difference?
So that you can also use manual for small things.
Yeah. Yeah. Awesome.
Essentially, are you like able to add like specific spans to like the general instrumented one that will give you automatically?
Yeah. Yeah. That's it. Good job. And what is the OpenTelemetry collector? What is it? Why do you need it? Why do you need it? And what does it do? I want to. You can answer only one of them. It's the buffer, but why? Then why would you use the buffer?
It's the impedance match between the source and the destination.
Yep, exactly. Both are correct. Raise your hand if you learned something here today. Wow, wow, amazing, guys. Thank you. Okay, you're free to go, guys. Have a great day. And thank you so much. Oh, so is it still recording? I don't know if I could show this. So I worked at this other company called epscon.com. We were purchased by Cisco about 1.5 years ago. So this website is almost down, but for example, I think I could show you the demo still. So this is a commercial product, Epsagon. Within Cisco now, we do have also App Dynamics. Let's see, maybe there's a demo. There is also Teletrace. This is a vendor neutral one that's open source, but it's very, very new. The Epsagon demo, so this is what Epsagon is really famous for. When you go to traces over here, and you click on it, this is basically a table full of your spans, and you could have a very sophisticated span search. That we're able to show spans like I've never seen before. And so you really get, like, forget even the waterfall. The waterfall is like a secondary one, like this timeline, right, that we see in Jaeger. So for me, this is really, really cool. They're able to see, from here, and we also collect also everything that happens. So for example, in the Lambda, we're able to not just get, basic metadata stuff. We can see also, let's see if I can see it. No. But for example, in this HTTP call, we see not just the headers very easily. We see also automatically the body and everything else. And also in the response, the headers and body. And yeah, it just works amazing. We can see for kinesis, everything. And yeah, for the database as well. So I would say this is even a sort of boring trace. If we can find some pretty interesting traces out there. And for example, even in the database, when you make a request and you make an insert, we can see the exact SQL statement as well. You could obfuscate it as well. You don't have to include it. But if you'd like to see it in there, we do have it, and this really, really helps in debugging. You can see, oh, this isn't the table I want to send it to, and this isn't the exact value I wanted to send in. I wanted something kind of different. So this is great for finding bugs that you didn't even realize were there, and maybe they even made it to production. And now you're realizing, okay, this is the issue, exactly. Does that answer your question? Yeah. Would you use something like this? Just curious. You use App Dynamics. Oh, that's cool. So use App Dynamics, which one? The OTel one or the non-OTel one?
So we don't use OpenTelemetry. We use most of their, well, they may use it under the hood, but we use most of their things for servers and applications.
Okay.
Anything good for asynchronous stuff?
For asynchronous?
Yeah.
Oh, I'm not sure.
No, they don't really have many tools yet for asynchronous stuff. So we're
Yeah, I do know that App Dynamics is moving towards OpenTelemetry as well with App Dynamics Cloud. And yeah, these are the ones I would recommend. Definitely Epsilon, App Dynamics, Teletrace. I think those are good ones. Okay, you're free to go, guys. Thank you very much.